Chances are the majority of the drawings you'll be printing in a production environment will not be plotted at 1:1 scale. Most often, the geometry you plot will be represented much smaller than it is in real life. Because of this, we need to have an understanding of our scale factor such that we can properly size our dimensions, our text, and our line types. Let's take a look at a drawing. I'm going to come up and click Open. And I'm going to look inside my Chapter 15 folder, inside the Exercise Files directory, and I'm going to come down to drawing number 7, Calculating Scale Factor. We'll highlight this guy and we'll click Open. Now on my screen is an architectural example. This is a floor plan of a single-family home. I'm going to zoom in on the master bathroom area. We'll pan this guy to the middle of our screen. Notice that I've added a call-out for a specific fixture I'd like to use in this bathroom. Now that call-out reads great on screen. Let's take a look at the layout. I'm going to come down and click on my layout. I happen to have one set up for an 8.5 by 11 sheet with a title block, and I have a viewport cut, and it's scaled such that what I see within the viewport will measure 1/16 of an inch equals a foot. Let's zoom in on that same master bath area. We can't read the text because, unfortunately, when I put in my text, I wasn't considering the scale of my plot. This is why our scale factor is important. If we understand our scale factor, we can properly size our text, our dimensions, and our line types. Let's take a second and talk about how to calculate our scale factor. The scale factor is the relationship between our printed units and our model space units. For instance, if I was to give you a scale of 1:1, what that essentially means is one printed unit is equal to one model space unit. So my scale factor would be 1. What if I gave you a scale of 1:10? What this means is one printed unit is equivalent to 10 model space units. Thus, I would have a scale factor of 10. 1:10. Let's look at a metric example. Now, in a metric drawing, quite frequently your printed units are millimeters. That's how your paper's measured. Let's assume the model space units were also millimeters. If we plotted our drawing at 1:50, our scale factor would be 50. Let's take a look at a civil engineering example. Same thing, 1:50. Now in a civil engineering drawing, our printed units are inches. Typically our paper is measured in inches. And our model space units are feet. Every unit equals 1 foot. So if I plotted something at 1:50, I'm essentially saying that 1 inch equals 50 feet. So my scale factor would be 50. Now you're probably thinking, did we need slides for this? Doesn't seem very complicated. The reason I showed you these was to prepare you for this, the architectural example. See, architects don't use the same type of scales as the rest of us. They use fractional scales. This is an example of a typical architectural scale. 1/4 of an inch equals a foot. Now in an architectural drawing, our printed units are usually inches, and our model space units are also inches. So at this scale, we're essentially saying that 1/4 of a printed unit is equivalent to 12 model space units. Try not to think of it that way. Instead, let's learn how we can calculate our scale factor when we're given an architectural scale. It's really very easy. All we have to do is flip the fraction and multiply by 12. So 1/4 becomes 4/1, which is 4. 4 times 12 is 48. So our scale factor is equal to 48. Let's try another one. Another standard architectural scale, 1/8 of an inch equals a foot. What's my scale factor? If I flip my fraction, it becomes 8/1, which is 8. 8 times 12 equals 96. So I have a scale factor of 96. Your scale factor is simply the relationship between your printed units and your model space units. Knowing how to calculate your scale factor is the first step towards creating predictably sized text, dimensions, and line types.